Welcome to my another video about the migration process. In this video, I'm gonna talk about the migration process from one control system to another control system. I'm gonna use ABB Symphony Plus Infi90 as our old control system and Siemens Power Plant Automation T3000, which is called SPPA T3000, that is going to be used as a new control system. First of all, the migration process I want to describe that can be divided into three basic steps. The first one will be the selection of the hardwares, that means the number of input and output cards, PLC, network component, Modbus devices. So these hardware components need to be selected based on the hardwares used in our ABB Symphony Plus Infi90 control system. For instance, if we talk about the number of input and out cards that will be used in our SPPA T3000, we can select this number of input and output cards based on the number of input and output signals used in our Infi90 control. And then we can select our processor, that means the PLC. So the PLC normally in our Siemens Power Plant Automation T3000 is S7400 series AC station, which is the high availability system. So this PLC is normally used in SPPA T3000 as a master controller. So after selecting the hardware, the second step will be the function block diagrams. That means the selection of function block diagrams available in our SPPA T3000. We need to identify the function blocks from SPPA T3000. Which function blocks will be used to do the same process that was being done by ABB Symphony Plus Infi90 control. That means that to do the same process previously what was being done by ABB Symphony Plus Infi90 control, we need to identify the function blocks available in our SPPA T3000 that will do the same task. The last step will be the HMI creation. That means in our Infi90 control system, especially in the ABB Symphony Plus operation server, let's say that we have 5 HMI pages. So these 5 HMI pages, we need to create the same outlook in our SPPA T3000 so that operator will be able to do the operation easily, because already they used to with the ABB Symphony Plus operation server. Here is the ABB Symphony Plus Infi90 digital input card configuration. As you can see that if I select as you can see, this is our digital input card configuration. That means here we are using 16 channel digital input card. The first 8 is for the first group and the second 8 will be the second group. So two groups of digital input channels, they form as a one digital input card. And if I go to the second page, so this is the cross reference of the first one, right? So if I go to the previous one, as you can see that this signal we are tracing here, this is 10BAA 11 GS011. This is our first signal. So if we go to the second page, 10BBA 11 GS011, this is the same signal. What I will create a new digital input card that will be 16 channel of digital input card. So to do that digital input card insertion in this SPPA T3000, that means if we want to add one digital input card in our SPPA T3000, first we need to go to the hardware section. So as you can see, I will add an CJP41 panel. So I will open this ED200 module. I will add one digital input card, which will be 16 channel of digital input card. So as you can see, this is our ED200 module, which has some other input and output cards already. So this is slot number 6. So I will add another digital input card, which will be slot number 6. So as you can see here, this is the last number page. I will add one page here. So as you can see, this is our last page, 5 number page. I will take the S7300 module from here, ED200 module. This is our digital input card. So this is 16 channel digital input card. So addressing of this card is done. Now the time of configuration of the signal. So the first signal is 10BBA11. So what I will do here, I will take that ticket. So I will connect the process value 1 and I will change as per the KKS number here. So 10BBA11 GS011, that will be 10BBA11 GS011, and I will check the signal XS01, same on that one. I will add one hardware and the name I will be renamed here breaker in. Let's check again what is the signal description. Incoming breaker closed. So I will rename like this, BBA 11 incoming BRKRCLSD. So this configuration is done here. So I can save. Now the another configuration, what I need to do is to configure the alarming section here, right? So this is our software pages. That means that when the breaker is closed here, it will give me one alarm, and I can show that on my HMI page also. So to do that, what I have to do, I need to take one Boolean signal monitor, and before that I need to go to the software page. For example, I will configure here. As you can see, I can configure that one here. So what I will do, I will check the base mon, or I can copy from here also. I will copy this signal and I will paste here. So what I will do, I will check change this value, and so I will change this one. The property will be this property, right? So as you can see that automatically it comes here, right? So I will create an alarm signal. So the output, I want to create an alarm. That will be, I can say, alarm type. And so now this is also set, but it is not activated. That's why it is showing here the black screen. So this is how actually we can do the logic configuration from ABB Symphony Plus Infi90 to Siemens Power Plant Automation 3000. That is the digital signal configuration. And if I talk about the analog signal configuration, the analog signal configuration also can be done using the same way. What we need to do is that we need to add one analog signal. Actually, we need to add one analog input channel. For instance, this is our analog signal. So we need to do some configuration from here. For instance, what kind of sensors we're using here. So the channels configuration. For instance, that if I talk about the channel 0, so this is our channel 0 engineering unit, and these are the configuration. Both are deactivated, so I need to check from the type of the sensor. For example, 4-wire signal, 4-wire 420 milliamps, which channel we will use. For example, 4-wire 420 milliamps or 1 to 5 voltage. Then we need to do the configuration. It will be percentage, the engineering unit, 0 to 100%, or what will be the output, like we can say if we select here pressure, and 0 to 100 bar. So the channel 0 and channel 1 will be activated at the same time. We can, as you can see, this is 0 to 100 bar automatically, and we need to add the analog signal. For example, 11 MBA 10 CP101 hardware XQ01. So this will be, for example, bearing temperature, bearing, or we can say this is our fuel oil ratio, and commit, and finally we need to activate. So as you can see, this is how we can do the configuration from ABB Symphony Plus Infi90 to Siemens Power Plant Automation 3000. So this is how we can do the migration from ABB Symphony Plus Infi90 to Siemens Power Plant Automation 3000. But what I already told you, that as you can see, if we want to create multiple alarming, so what we need to do is that we need to take ASMON block. So we need to take the ASMON block here. This is our analog signal monitor. So visible port. For example, I will use this signal here, 0 to 100, and this is our signal description. So this is our signal description. And now what I will do, I will change this output, and definitely what I will do is, it is automatically taken here, XQ output, XQ. So I can format this. The tag number will be this one. That will be our fuel. That will be fuel oil pressure. So this is our fuel oil pressure. Format done. If I look at, this is fuel oil pressure. So 10 MBA 11 CP 001. So this is how I can configure our signal from ABB Symphony Plus Infi90 to Siemens Power Plant Automation 3000.